Thank you, sir. At the outset, I would like to thank our management, our Chancellor ma'am, the President sir, the Vice Presidents for providing us such a platform uh, which will ensure that the learning process does not stop. So for this, we are very grateful to the management. I also thank Dr. Sheila Rani ma'am, who has provided this conference, this uh, program for us, wherein we have the opportunity to interact with a lot of people and thereby share the knowledge that we possess. So with this, I also thank Dr. Inbakandan, who was courteous enough to include me in this presentation. So thank you for the talk, sir. So with this small accolades, I would like to get into the presentation without much ado. So let me share the screen. Sir, I'm not allowed to share the screen. Can you just make me the co-host, please?
Sure, sir. Sure, sir. Please try now, sir.
Yes. So my screen is visible.
Yes, sir. Yes.
So before starting, I would like to know about the participants. I don't know whether they will respond or not. But one thing is, uh, I hope many of you are from the scientific background where you people are publishing papers, working on your research day in, day out, and producing a lot of these scientific data. And they say that out of all the data that we have today, 90% of the data was generated in the past 2 years. So that's a tremendous amount of voluminous data that we have in our hands. And today, data analysis, data handling has become a topic on its own. And many professions have emerged out of this data science. And as scientists, I be a small time scientist or a high-end scientist who works with the cutting edge technology today, coronavirus, everyone has one point in hand. They will be doing tremendous amount of research work, wonderful data would be generated. But then when it comes to presentation, that is where they need to effectively present their data to the audience. A general table with just numbers is not liked by a lot of people. Of course, I think many of the people who are here, they have a biology background and they have taken biology as their subject because of their aversion towards mathematics. But today, we are in a position where we do understand that mathematics is uh, in every field. As they all say, maths is the mother of all subjects. So it has to be accepted. And without mathematics, it is not possible. But whenever biologists, we hear the word mathematics, some kind of a jittery wave passes through us. But then thanks to technology, we have very good technologists who have come up with a lot of programs, lot of platforms in which we can easily work and easily produce the results that we aspire to bring. So we are into this era wherein we are trying to present our data effectively. So everyone presents data. So how is it that we are going to present the data effectively? So this session aims at introducing you to R programming, the R environment, which is most widely used by scientists around the world. So let's get into the topic. Yeah. Okay. So this is the end of day presentation that we all have, the problems that we have. We would like to show our data in different ways. We can broadly classify it in 4 different ways. Either we can show our data by comparison, wherein we have a lot of different charts. We can otherwise show our distribution data. Again, a lot of different possibilities are there. Scatter plot, column histograms, distribution plots are there. Composition, what is it composed of? A pie chart, a traditional one. Then relationship charts. Charts are everywhere. So charts, they make the world. We have seen a lot of these charts in many scientific journals. We might have used all these. So broadly speaking, when we say data visualization, it comes under these 4 categories. Either it is comparison, distribution, composition, or relationship. So this is where we try to work with our charts, with our data. So what would you want to show with your data? What is it that we exactly want to show with our data? One thing is, sometimes we look at a time series, or it might be a ranking data. Sometimes a part to whole, a ratio type of data is what we'll be working with. Sometimes it might be deviations, right? And distribution, correlation, comparison, these are some of the aspects that we would like to project to the audience. See how my data is comparing with that of the other person. See how it is correlating with the existing drug. So a lot of these data is what we try to show in our research papers. So for example, this is a time series one in which we try to show values which has changed over time. Over time, you can see the effect of the drug. Is it peaked out and then it is coming down, or is it a constant increase? So we use a line graph, a bar graph, a dot plot, whatever. Right? A lot of different methodologies do exist for time series data. Sometimes we have ranking, wherein we try to show the values which is ordered by size, either in descending order or ascending order. So that is there. Sometimes we have ratios, which are just parts which we try to project. And the most commonly used one, which is the pie chart. When we look into the pie chart, generally it takes us back to our school days, because pie chart is the one diagram that we do in school, wherein everyone will get excited. We draw different kinds of colors or different kinds of patterns in the different parts. However, what happens is it is hard to judge the relative size of the pie slices sometimes, right? And it takes up a lot of space to present very little information. And it requires labels. When there is a small space, you cannot do the labeling there. And a good color contrast is very important for a pie chart. Otherwise, it will not be as effective as it is, right? So then we have the deviation charts, where there is a difference between two sets of values. And then we have distribution charts, correlation analysis, normal comparison. We do all these things. So what is it that we are trying to do here with all these different types of charts? We use these schematics, illustrations, and flow charts to explain how an experiment was conducted or a design concept was conceived for an engineering project. This is what we try to do with all these schematics, illustrations, and flowcharts. And once we do all these things, then we get the data, and then we tabulate these data. And using statistics, we try to do some sort of an analysis. That's what we try to do. And then we have some photographs also, right? Of course, a picture is worth 1,000 words. So that's, a picture cannot be replaced at all. And this is where we try to adhere to some data presentation standards whenever we compare, or whenever we come out with the research work in any field of research. So there is a sort of an expectation when it comes to data presentation in every field. So the first thing that a reviewer is being asked when he reviews a paper is that, are there any graphs in that paper? What kind of graphs are there? What kind of statistics have they used? And can you review the schematics and any special uh, style guide the journal has? So these are some things that generally people look into, and each and every field has a unique combination of all these things. So which brings us to one common agenda wherein there are a few best practices when it comes to visualization. There are some best practices. First thing is, you have to emphasize on the most important data. This is very, very important. You should not, just because we say that visualization is important, immediately you cannot have photographs right from the beginning to the end. It doesn't make sense, right? So what is most important? How do you emphasize on that? That is the key. Number one, best practice. Number two is, how do you orient the graphs for better legibility? Right? Whether you put it a horizontal bar graph or a vertical bar graph, or where do you give a bar graph or a line graph, which type of graph? So that becomes very, very important. And a good organization of graphs and table, a combination of these graphs and table, will visualize the data much more fantastically for the audience. And as usual, as they say in Tamil, uh, anything, even if it is going to be a very good uh, drink, if you are taking it too much, it's going to spoil your health. So you have to avoid overloading of graphs. And then you have to limit the number of colors and shapes or things that you use. And you have to always inform through important, whenever there is an important thing that has to be informed, then you have to use some text material in a visual graph. So these are some of the best practices that we have in visualization. So that's about visualization. Where do we go? So we go into statistical software. And that brings us to the next question. So what do we do now? Early days, people were using just plain hands, and they were drawing pie charts and they were drawing bar graphs and other things. Then later came Excel, Microsoft Excel. So Microsoft Excel was making the job of a scientist very easy, and people were much comfortable using Excel. So they were able to make graphs in seconds. So it was fantastic, really fantastic. But then a specialized statistical software was the need of the hour. So that brought the scientists together, and they had certain command line softwares. Command line softwares are like, you might have seen the early days. There will be a black screen, a DOS computer, a black screen, where you need to type some commands, and it requires extensive knowledge of the syntax of commands, and you can reproduce the results through scripts, but then detailed analysis is also possible. But this command line software is not that much user friendly. It is not pleasing to look into. So in order to overcome these, people brought out this GUI-based software, graphical user interface. Graphical user interfaces are the one that we are using now, Windows or Mac. These are all GUI-based softwares, which does not require knowledge of commands and not reproducible action. See, it is very easy to use. You need to open some software, you just go double click it. Right? So that's as simple as that. So statistical softwares, there were plenty in number. They came, there were hybrid types also, both command line and GUI-based softwares came into existence. And that is where we had this R evolving slowly. It is a software package for statistical computing and graphics. So you can do both statistics over here as well as graphical analysis. So this was the advantage that R brought us. And yeah, just okay. So there are a collection of somewhere around 6,700 packages That's of to 2015, right? So it should be more by now. So you can make a package of your own based on your requirement. So that is the flexibility that R provides. And it is not ideally a programming language, which means that you need not be knowing much of a program to understand this. This is both our programs, our software's disadvantage as well as an advantage. See, today, when you look into the scientific world, there are two things that come when you look into data presentation. There is a tough competition between uh, two programs. One is R on one side, the other one is Python. So Python programming is for programmers, people who love programming, people who like to do write some codes, scripts, and other things. But then R is for scientists. Generally, it is for biologists, and that is where R stands out much closer to biologists who have a slight aversion towards this computer science and other things. Right? So technically, R programming is for biologists, and it has a very good work environment, and it is widely used. As I said, it's powerful. Most importantly, it's free. Right? You need not pay anything. So that shows the number of R packages that has been increasing. You can see that in 2002, the number was in hundreds. Today, it is in thousands, right? So the number is increasing logarithmically. The number of packages are increasing logarithmically. So if you look into the history, there was a S program that was written by Bell Labs in 1970, and R was created in 1990s by Ross and Robert, hence the name R. And R was based on S, but it was a code which was written in C. C was considered to be a powerful language those days. And there was a tough competition between S and R, but then today we have uh, R, which is fantastically developed, and it is giving us wonderful graphs like this. Right? So you can see the different types of graphs that are being produced by R package, and they are being used for publication much easily. This is another G-Galley package that is in R, which can produce a lot of different graphs, different types of graphs. So we can see from here that technically a lot of these scientists, they're using R for their research work. Early days, people were using SAS, and then they switched on to SPSS. And today, R has become the most preferred language, the most preferred software for data analysis, as well as for statistical analysis. And it has pushed MATLAB, the Statistica, the other types of statistical analytical tools way far ahead. One of the main reasons is that R is free and R is flexible. The same reason why Python is also becoming much more uh, competitive. So R as such has its own integrated development environment, or IDE, which is the graphical user environment, and it's called as R Studio. So for us biologists, as I already said, we don't want to look into that black screen, typing in white, that black and white combination. No, we don't want that. We want an integrated environment which will be much more interactive, and it will be easy for us to look into the program. So R Studio is part of R, and today we will be learning about this R project, and we'll be looking into the basics of the basic idea of this talk is to introduce you to R. I'm not going to get into the details of R programming or R, which is not possible for us to finish off in half an hour or 1 hour. It takes a lot of time. But then the intention here will be to tell you on the ability of R programming, the ability of the R software, and how easily you can integrate this in your research work. So as I said, R is a free software and environment for statistical computing and graphics. You can download it from this website, rproject.org. So once You download it. You can see this is the website. You can see a download at the left, and you can select whichever country, and then you can download based on your system. If it's a Linux system or a Mac system or a Windows system, whichever one, you can download that particular uh, R, and you can install the same in your system. Windows R for Windows, of course. Uh, that's with the basics of R. Now, once you have installed R, what next? So what is it that we do? Let me show you the R Studio. So this is the R Studio. Now I have double clicked and I've opened the software. You can see the console over here. And let me take the, I don't have the tools here. Right. I hope you can see the terminal. This is the R platform. This is the place where you are going to type all the codes. Don't worry, it's going to be very simple. And this is on the right side, you have the environment and the output window over here at the right bottom. So the left hand side, you have the console. The console is the place where we are going to type whatever we want. Now R is so very flexible, you can just use it like a calculator. For example, you just can type 5 plus 8. Voila, there goes the answer. You want to multiply some numbers, 15 multiplied by 84, you get the answer. Right? So it is very simple and very intuitive also. Again, can I do some programming over here? Yes. For example, print. I'll type the famous one, hello world. Yes. And there goes it. Okay. So this is one easy way of using R. And if you are wanting to do some kind of a statistical analysis, for example, I want to find out the mean of certain numbers. Let's say I want to find out the mean of 10, 20, 30, 40, 50. Sorry, that was a mistake. So I'll just give you the command for mean, t-test, median. Just hold on a second. I didn't get that. So before giving out mean, we need to assign all these numbers to a variable, just like storing them in a variable, and then we have to find out the mean. So that is something that we do. So for example, I'll store all these numbers. X is equal to, okay. This is one way of storing numbers in
Excuse me, sir. Sir, your screen is not visible, sir.
Just give me a second. Just
yes.
I didn't share the screen.
Yes, sir. And now,
okay.
yeah.
Okay.
Yeah, now it is. Yes. Yes.
Yeah. Okay. So I'm using a variable X, and in this variable, I am storing all the data 10, 20, 30, 40, 50. So that's one thing that I do. And to the right, you can see that the data is being stored in the environment. There is a variable called X, and there are some 5 different variables which are stored over there. So now I'm going to put type as x is equal to mean of, sorry, y is equal to mean of x. Then I print y. There you go. So similarly, you can do put up an array of numbers, you can do t-test, uh, all sorts of statistical analysis. It's just a simple line that you need to enter, and then you can go ahead. Now, I don't want to confuse you with all these things, because if you people are interested, certainly there are a lot of programming help that is available online, and you can find out all these small formulas that you can use for mean, median, mode, and all those things over here. But today we are going to, I'll be introducing you to the other part of our programming, which is data visualization, for which we need to have a special package called as ggplot. So for the convenience, I'm not going to take much of the time, so that in telling you about the program and other stuff. So I'll just enter the program, and part of the program I'll explain, so that it'll be easy for us to look into. So again, this program was taken from the internet. So you can also do the same. So you can also get the program. Again, I have to share the screen. So, yes. So here you can see that I have got this program. So if once when you become a master of programming, you can write similar programs over here. And in any of these programs, this hashtag will be used to indicate that it is a comment line. So in this, we have this library ggplot. So once we are installing this ggplot, so I've already installed ggplot, so it's ready with me. So you can see that whatever I do, it comes up over here at the bottom. And then the next one is, I'm going to use a data now, which is something which everybody knows, right? I'm taking the data of what happened to the Titanic, which is available online. The number of people who traveled in the Titanic, their age, their number, the passenger number, and all those other data. I'm trying to take all these things. So just hold on a second. Just give me a second. Yeah, sorry. So why am I taking data of the Titanic? What is the data that I have taken? I have taken an Excel sheet. So you can see that I'm reading the Excel sheet. I've asked R to read the Excel sheet, titanic.csv, and it is doing so, and it is showing in the global environment over here. There are somewhere around 12 different variables, and much data is present inside. In order to visualize what sort of data is there, I'm writing a code over here. You can see I'm asking our program to show the Excel sheet to me, and it is showing me the Excel sheet over here. So the Excel sheet itself has data like this. This is a passenger ID, the first column. The second one is survived, yes or no. Survived 0 is didn't make it. Survived 1 is made it. He's alive. Right, and then the next one is the passenger class. Which class did the passenger travel in? The first class, second class, or third class? And then we have the name of the passenger, then the sex, the age, whether the passenger traveled with the siblings or spouse, right? And whether they traveled with their parents or children. So this is the second one. The next column, the ticket number, the fare of the ticket, which cabin they were in, and then in which place did they embark, or which place did they board the ship. The ship was supposed to take passengers from 3 different places. Southampton, another 2 more, Queenstown, and another place I forgot. So 3 different places. So this is the data that we have. As such, when you look into this data, it's a huge data, comparatively huge data, and we don't make much out of it. If it's given as a table, you look into the table and you don't get much information out of it. Now, this is where we get to write some programs wherein we try to visualize this data and see how good this data would be, right? So first thing I'm trying to do over here is, so here you can see the output, right? I'm trying to see how many of them survived. So that gives us a bar graph, right? So here you can use a bar graph. I am asking R to make a bar graph out of how many of them survived and how many of them didn't make it. So it's given me a easy bar graph, and you can see the lines over the number of programming lines that I've used is only 2 lines. ggplot Titanic, comma AES, X is equal to survived, then geom bar, that's it. And I have got two wonderful graph over here, which says number of people who were dead and number of people who survived this. But then many times we are not interested in looking into the graph. We want to know the numbers also, the percentage also. So you do a small calculation, and here you can see in the left bottom, it gives you the percentage. 61% didn't make it, and 31%, 38% survived. So that's a percentage wise calculation of how many survived and how many were able to make it. So why am I using this data? Because see, Titanic is one thing, one phenomena that everyone understands, and everyone knows the background story of what is what, right? What happened to the Titanic, and why so many people died, and the conspiracy theories. Many people are into the conspiracy theories also. So for us, we are just trying to visualize the data so that it will be easy for you people to know all these things. Okay. So second thing is, now the next question was, how many survived based on gender? This is our next question that comes to our mind, isn't it? See, we looked at the survival rate first. Then the next question is, okay, so how many people, how many males survived, how many females they survived? So this again is by a small program, a small 4 lines. We can easily ask R to give us a graph. See how easily it has given us a wonderful graph wherein you find the passenger count, and the moment you look into it, it is obvious that there were many females who survived compared to the males, right? The number of female were less compared to the male. So many, at the simple sight of this graph, many inferences can be made, right? So this is the advantage of R, and this is how it tells you about easily, or it easily interprets the data for you. So when you are writing a discussion part for your research paper, such graphs would be of much use to you, right? It will give you a lot of information. So, and again, making these graphs also is not going to be a very tough task also. So the next thing is, okay, so I want to find out the survival rates by the passenger class. Okay, by gender, we found that females, they survived more, but then by the passenger class, if I want to look into how many people survived, can I have the data? Yes. So you can see that the first class passengers had a better survival rate compared to the second class passengers and the third class passengers. And a lot of people who died were from the third class, right? So at the moment you look into this, you'll be able to make out what happened on that ship. So this is one way. And as researchers, many times it will be not enough for us to look into one graph separately. We need combination of graphs, a combination of factors. That is something that we do regularly, right? The effect of this one and that one, the effect of this one on that one. So we do a lot of these combinatorial studies. So here, a similar analysis has been made, and you can see that here at this graph, it gives you the passenger class, first class, second class, third class. It has categorized into 3 different bars, and it has grouped into 3 different bars, different groups. And amongst the first class, the female and male. Amongst the second class, the female and male. Amongst the third class, the female and male people who survived and who didn't make. Right? And can someone tell me, because it's been monotonous, me talking for a long period of time, can someone interpret this? What are the things that you find out from this graph? Or what are the information that is available to you from this graph? I think
participant, you can interact.
Okay. See, the moment you look into the graph, you will see that all the female passengers of the first class and second class, almost they made it, except for there's a small number who didn't make it, right? So if a passenger has a female passenger from a first class or second class, certainly they would have made it. On the other hand, if you look into the male candidates, the males in the first class and the third class were okay, but the third class, you look into the number of males who were there, the percentage of males who were there in the third class who survived, which is very, very less. So the chances of people who survived from the first class being a female is more, right? So this is a lot of information that you get just from one simple graph, right? So this is the type of information that R provides you easily. Just by writing a few codes, a few lines of code, you can make these facets, and you can just drill down into these data and get a lot of information from it. So that is one part. So the next component that we might be interested in is looking into the age distribution in Titanic, the people who went and the people who were part of Titanic travel. So if you look into the age distribution, this is a distribution graph. Of course, this is a histogram, and you can see that it's easy for us to see that most people within the range of 20 to 40, they were the ones who traveled a lot. Right? And that's very easy. And you can adjust the size of the width of this histogram according to your need. If you want a larger width histogram, that's also is fantastic. We can easily make it. So now we are drilling down more into this histogram by looking into the age as well as the survival rate. Survival rate based on the age. And the moment you look into it, you can see that small children below 20, they were able to survive more, right? And compared to the middle-aged people, smaller people were able to survive more. The survival rate is more, because you can see both the histograms almost like touching each other at the left corner, and somewhat at the right corner, it is 50-50 here and there. But in the middle, there is a vast deviation. So that shows that there is a very big difference, right? So if you are young, the survival chances of survival were more. So that is one of the key things. And you can look into the survival rates by ages. Again, that's a box plot. So you can see how the box plot has some outliers also. And the information is clearly visible over here in the box plot. The average age, everything will be given to you just by one click of a button, right? And oh, sorry, I just overshot this one. Yes. So this is another facet. We can use different facets to have uh, survival rates by age, passenger class, and sex. Just give me a second. I need to take this. Sorry, I had to take the call. So this is the Titanic survival rates into different facets by age, passenger class, and sex. So you can see that the females in the first class, we already saw that they were able to survive more, and the children in amongst the female, it's almost like everyone in the first class female, they were able to survive. When you look into the second class, same is the case with the case of female, and irrespective of the age, they were able to survive. The survival rate was more. It is only when you look into the third class wherein the females were a little bit affected compared to the first class and second class. And in the case of the males, you can see that the first class, second class, third class, there was a gradual increase. There was a gradual increase in the number of fatalities when it came to the males and class wise. So this sort of a comparison will make things easier for us, right? And yes, so that's with survival rate of age. Yeah, I think I have come to the end of this. So this is how maybe R programming can be used for a comparison of data, for easily producing fantastic visualizations. See, what I've given you is just one two-dimensional view of what R is capable of doing. R is in fact capable of layering information, layering output, but that will become a very big talk, and it will take a lot of time. Today, I heard that some people are moving towards Tableau, which is comparatively a simple, say, visualization technique. That's what many people say. I have not explored into Tableau, but then my experience with R is that since it is more good at statistics as well as visualization, I think learning R or spending some time in learning R and using it in your research will certainly enhance your research much more effectively compared to the others. So it is up to you, of course, but still, I prefer that. I really wish that at least you'll be using R in your future research work in the years to come. So with that, I think I come to the end of this session. I hope I've made my point at least through to a few. I've covered about 80% of what, sorry, 20% of what 80% R is capable of. So it's up to you to build on the rest. Thank you for the opportunity once again. I would be happy if you have any questions for me. Yes. How to explore the graph? I think the question is not clear to me. Um,
No, the question is how we can export the graph to the our
Okay,
studio.
exporting the graph. Yeah,
So-
you can take that. Right. I didn't show that one. Maybe. So this is R and you have this output. You can zoom into this one full screen. You can just take a screenshot of it if you are, or you can snip it or whatever you want, you can do it, or just you use this export button over here. You can save this as an image, you can save it as a PDF, or you can copy to clipboard and put it in your Word file even. So all options are available.
So if I want to use my own uh, Excel table,
Yes, sir.
so how I can import that here?
It's a simple read one over here, sir. So first command that we give is read. So the code, if you just go line by line, you can see that I have imported. This is the line that wherein we have imported the code read.csv, titanic.csv. So this Titanic Excel sheet is actually saved as a, in Excel you can save it as .csv.
Okay.
And if you give that as an input, R will be able to take it up, sir. Yes. So I don't know how far I have reached with people. I don't know.
Vinith, can you unmute Dr. Lata? She want to interact with
Yes.
Ramesh sir. it seems.
Yeah, ma'am, please go ahead.
Sir, good evening, sir.
Good evening.
It is really nice.
Thank you.
My question is, if we download this package, we can do all the things. Just we can write, as you said, now how to import the data.
R is a
whatever
software,
data.
ma'am, that you have to download. Once you have
Okay.
downloaded, you have to install ggplot
ggplot. Okay.
library. You have to install that one inside R. There are a lot of
Okay,
packages.
inside R.
Inside R, you
Okay,
have
sir.
to download this ggplot. Ggplot is just one of the packages. There are plenty of
Okay.
packages. As I have already said, gg belly is another one, which ggalley is another package which gives much more informative visualization. So ggplot
Okay, sir.
actually it works in between, and we have a lot of other statistical packages also. So
Okay.
based on the requirement, we have, you can download whichever package you want and you can install.
Okay, sir. Thank you. Thank you.
Thank you.
Vinith, I think Dr. Nidhi also want to interact with sir. You can.
Good evening. Good evening, sir.
Good evening.
Sir, I just wanted to know that suppose we have a raw data file, like I'm using Minipam for my research work.
Minitab.
So Minipam.
Okay.
Minipam, yes, sir. Photosynthetic analyzer. So we get a raw data from the instrument. So do we have to convert the file if we use for this R Studio?
Obviously, you need to provide it as a .csv file.
Sir, kindly repeat. Dot.
You have to convert it into a .csv file if you want to work with Excel file.
Yes,
But
sir.
then I'm not sure about what extension your instrument gives as an output.
Sir, it's in Excel only.
Excel only. Then it is
Yes,
very
sir.
easy. You can convert it into .csv. You can save it as .csv. Any
Okay.
file name .csv, and then you can use it directly in R.
Okay, sir. I can just import that file into the
Into
this.
yes, read.
Yes.
You can use the command read, and R will read it for you.
And so, like you were saying that there will be different graphs, like you showed us in your slide. We will be getting the comparative study like that only.
Yes, that is just part of that is what I told you, right? I'm
Yeah,
just
we have to
introducing you
explore.
just 20%
Yeah.
of what 80% R
Yeah,
is
yeah,
capable
sir.
of. There is plenty of other options also. Whichever
Yeah,
one you
yes,
want,
sir.
you can do it.
And sir, one more thing, sir, like you said that you have imported the data file from the internet. From which site we can get it?
This is from a GitHub site that I got it. You can just search for Titanic machine learning Kaggle.
Okay, okay. So,
Then
madam,
you'll
we
get
can
it.
we can directly write the keywords.
Yeah. You can
And
look
search
into.
the data file. Okay, sir.
Yes, yes,
Okay, sir. Thank you very much, sir. Very
Thank
nice
you.
presentation.
Thank
Thank
you.
you, sir.
Thank you.
Sir?
Yes.
Yes, sir. She asked regarding this photo or microscopic images we have, no, sir.
Yes.
So in the word, we have actually how to export it to this and
Ma'am, you are talking about image analysis.
yes, sir.
No, we have talked only about data analysis, ma'am. Image
Data
analysis will be a completely different package.
Okay, is there any option or
Yes, ma'am. We
in
have
this
different packages for image analysis also. We can do text processing, just like how we do it in LaTeX. We
Okay.
can do image processing, just like how we do in Minitab or other softwares and MATLAB. We can use the same, or we can have different packages for individual purpose, ma'am.
Okay, sir. Okay, thank you. Thank you.
Participant, is there any other questions? Or shall we end this session 1? Hope there is no furthermore question. Thank you, Dr. Ramesh, sir.
Thank you, sir. Thank you.
Thanks a
very much
lot.
for
It is very informative. Even it is
Thank
very informative for a Center for Ocean Research people, and we want to learn more from you.
Thank you, sir.
Thank you,
Always.
sir. Thanks a lot, sir.
Thank you.